Hi everyone, my name is Francesca and I will present this recent preprinting collaboration with Xining Chu and Sueyon Chang. So our goal broadly is to find some good metrics for representation efficiency in order to study population analysis of neural recordings. And so in particular, we consider neural manifolds. Neural manifold is just the collection of neural responses that are elicited by some inputs that all correspond to the same object or concept, but include some variabilities. For instance, pictures of this cat that have different orientations, colors, pose, and so on. And so we have some structures of concepts in representation space, and we want to understand how their structure is related to their functional roles. And so we need to define some metrics of efficiency. One such metric that has been proposed is manifold capacity. And this is a result of some works in recent years by Sueyon Chang and collaborators. So basically, this amounts to computing the maximal load, the critical load of these manifolds that can be separated by an hyperplane. And this threshold defines the capacity. So in other words, this capacity is a measure of the linearly decodable information that is available per neuron, and so somehow encodes the representation efficiency. And it can be derived as an exact expression, and it turns out that it only depends on some geometric properties of manifolds, such as radius, dimensions, and so on. However, there is a limitation of this theory, and it's linear separability. Because although this is very relevant toward the later stages of information processing, where manifolds are highly separable, towards early stages of information processes, neural manifold would be highly tangled and the linear separability would not detect much. So our goal would be to extend this theory. And for example, we can have non-linearly separable representations where the inputs coming from two different concepts like cat and dogs have highly diverse origins. So in this case, imagine that we want to classify this stimulus, well, we would not be able with linear separable tools. However, if we introduce some side information or some context, for example, what's the style of the stimulus, realistic, what's the sensory modality where the stimulus comes from, visual, then we will restrict our decision to a subset of the neural state space, where maybe it's easier to separate these manifolds. So the idea more broadly was to introduce contextual information into this framework to support nonlinear decisions. And this is a simple example, and we consider half-space gating in this case to implement context assignment, but actually context dependence is a much more general paradigm for brain computation that arises in many different situations and at various scales. So it was interesting for us to incorporate context into this theory of manifold structures. And we could do this basically deriving an exact expression for the capacity in this regime using some techniques that are rooted in statistical physics of disordered systems that allow us to derive an exact expression for this threshold that depends on various aspects such as the number of contexts, the correlations between this context and the way they are defined, as well as the structure of the neural manifolds and their geometry. And basically this framework couples contextual geometry to manifold structure. And the exact expression of the formula is not very important, but what's interesting is that we can evaluate it directly on deep networks. So basically what we can do is that we probe the separability of representations, but also with the piecewise linear separations across layers. So here the yellow line would be what we would get without context. And you see it's very flat, because linear separability does not emerge until maybe a little bit towards the last layers. However, if you allow for more expressivity and more context, you see a much richer phenomenology. So you can see that actually even intermediate layers are responsible for representation disentanglement. And if you have enough context, you can see that even the very early layers are already separating representations. Okay, I will be very curious to know your feedback, and if you want, please come to my poster today.